Hello, my name is Alex Carver. I'm a Senior Solutions Engineer with Pure Storage, focusing primarily on VMware products and our integrations with them. Now, what we're going to do isn't so much vVols 101, more 201 here. And that's how vVols works with change block tracking. First, what is change block tracking? Change block tracking, often referred to as CBT, is exactly what it sounds like. It's keeping track of the change block or the blocks that are allocated to that VM, so that in the future they can be queried against to find out what blocks have changed. And so it keeps track of that so that you can go ahead and refer to it to know these are the blocks that have changed on this virtual disk, and then be able to do something with them. Primarily, this is actually used with VADP, which is vSphere API for data protection. So VADP. Now, different vendors use this as a method to go ahead and back up a VM. And more particularly, to be able to efficiently take incremental backups of the VM. So they don't have to scan through every block on that virtual disk. They can go ahead and do what's called a query change disk area. And this query will go ahead and check against the baseline of that VM when it was taken, find out what blocks have changed, and then go ahead and read through those blocks and do the differencing for the incremental backup. This just makes it so that there's less content that's actually transferred across the wire, and so the backups can be quicker. Now, how do vVols work with change block tracking different than VMFS? Well, recall that vVols-based VM has those granular objects on the array, meaning it has its own volumes, its config, and for each virtual disk, a data vVol. And these are volumes directly on the array. And that array has its faucet provider that vSphere is going to communicate to be able to actually figure out what's going on. So when you enable CBT on the VM for the first time, and then take that managed snapshot, what ends up happening is VMware wants to go ahead and create what's kind of called a CTK file. And that CTK file, change tracking, is created for each virtual disk for that VM, with the purpose of knowing these are the allocated blocks that at this point in time this snapshot was taken, so that it can be referenced against each time that it wants to find out, all right, since this baseline, what are the changed blocks? In order to do that, when a VMware takes a managed snapshot, it goes through that process where it does the prepare snapshot virtual volume. We create the data snap volume so that we can then copy out. But before it actually goes ahead and issues the snapshot virtual volume, it stuns the VM. So that VM is stunned. And then it does a bunch of queries, essentially, that are trying to figure out what are the allocated blocks. And so it's a allocated bitmap virtual volume call, essentially. And we'll call that ABVV. That's actually the API itself that's issued. And what it's essentially doing is it's doing a scan through that data vVol to ask the VOS provider, what are the blocks that are actually allocated? It doesn't want to know what is in the blocks, because that'll all be done over the actual SCSI reads. But it just wants to know what are the blocks. And so it does a crawler scan through each of the segments for that data vVol. And then it keeps a track of, all right, these are the allocated blocks in that CTK. So that it then can query against it in the future. And it's a query change disk areas. So query changed disk. So in the future, when it takes another managed snapshot, it could then query against that to find out what are the different blocks, what's the change here. And then that way, the different backup vendor can then just query only those blocks, or read, I should say, only those blocks, and then do the incremental backup from and the differencing. So it makes for a more efficient backup process. And the reason why this is a little bit different with vVols is that, as I said, the VM is stunned when it starts doing these bitmap calls to find out what is actually allocated. And the quicker the VOS provider can do that, the less stun time there is. And then once those are done, it then does a snapshot virtual volume, and then the VM's unpaused once that's done. But it is something to take into account, that the stun time potentially could be longer than with VMFS, depending on how long the VOS provider has to take for that. Generally, it's only going to be a little bit longer, but depending on different circumstances, it could be a little longer than VMFS. So you don't want to do it during peak uptime, peak I/O hours, or whatever the case may be. So you want to make sure that you plan when enabling CBT or doing a CBT refresh, so that change tracking file is a current baseline and not something from a year ago or 30 days ago or even 10 days ago, so that query change disk areas is basically returning as few as blocks as possible to then make the backup process as quickly as possible. So it's a thing to plan around, but this is essentially how change block tracking works, specifically with vVols, and why it is important for backup process and for V80P to work efficiently with vVols.